Good morning, students. Today we discuss about general properties of amino acids. In the last class, already we discussed about classification of amino acids. In the last class, we learned about classification of amino acids. Now we discussed about general properties of amino acids. In these general properties, first of all, we discuss about physical properties. Amino acids are available as colorless crystalline solids. Amino acids are available as colorless crystalline solids. These amino acids having high melting point values. Okay, students, all amino acids having high melting point values. Why amino acids exhibits high melting point values? Amino acids containing salt-like structure. Generally, salts containing ionic bonds, ionic compounds exhibits high melting point values. Okay, students. Similar way, amino acids containing salt-like structure, because of this salt-like structure, amino acids exhibits high melting point values. Okay, these amino acids are soluble in water. Generally, salts are easily soluble in water. Salts are easily soluble in water. Amino acids containing salt-like structure. So, amino acids are easily soluble in water but slightly soluble in alcohol and dissolve with difficulty in methanol, ethanol, and propanol. Okay, students, amino acids are not easily soluble in methanol, ethanol, and propanol, but easily soluble in water, slightly soluble in alcohol. Amino acids exhibits both acidic nature and basic nature. So, amino acids are taken as amphoteric compounds. Amino acids exhibits both acidic nature and basic nature. So, amino acids are taken as amphoteric compounds. Okay, all amino acids except glycine, all amino acids except glycine are optically active compounds. All amino acids except glycine are optically active compounds. What is the definition of optical activity? If an organic compound rotates the plane polarized light to the right side or left side, that organic compound is taken as optically active compound. If an organic compound rotate plane polarized light to the right side or left side, that organic compound is taken as optically active compounds. So, except glycine, all amino acids exhibits optical activity. Why glycine not exhibit optical activity? Optically, why glycine is optically inactive? In glycine, asymmetric carbon is not there. In glycine, asymmetric carbon is not presented because of lack of asymmetric carbon in glycine. Glycine not exhibit optical activity. So all amino acids except glycine are optically active compounds. If an organic compound rotate plane polarized light to the right side, that organic compound is taken as dextrorotatory compound. Okay, if an organic compound rotate plane polarized light to the left side, that organic compound is taken as levorotatory compound. So these optically active compounds are divided into two types. First one is dextrorotatory compound, second one is levorotatory compound. If an organic compound rotate plane polarized light to the right side, that organic compound is taken as dextrorotatory compound. If an organic compound rotate plane polarized light to the left side, that organic compound is taken as levorotatory compound. So except glycine, all amino acids are optically active compounds. Lack of asymmetric carbon atom or chiral carbon atom, glycine not exhibit optical activity. Okay, students. Amino acids have high melting point values as compared to the compounds containing similar groups and having comparable molar mass. Amino acids having high melting point values as compared to the compounds containing similar groups and having comparable molar mass. For example, lactic acid and alanine. For example, we take lactic acid and alanine. In lactic acid, CH3 group and COOH group are presented. In alanine, CH3 group and COOH group are also presented. So lactic acid and alanine having similar groups. What is the formula of lactic acid? CH3 CHOH COOH. Okay, this is the formula of lactic acid. This is the structure of lactic acid, CH3 CHOH COOH. So in lactic acid, CH3 group and COOH group are presented. In similar way, in alanine, CH3 group and COOH group are also presented, but melting point of lactic acid is 4 degrees centigrade. Melting point of alanine is 297 degrees centigrade. What is the reason why lactic acid having low melting point value compared to alanine? Okay, why lactic acid having low melting point value compared to alanine? Because of salt like structure, because of in alanine having salt like structure, this salt like structure, it is containing high melting point value. What is the general formula of amino acids? What is the general formula of amino acids? Are CHNH2 COOH. This is the general formula of amino acids, or CHNH2 COOH. This is the general formula of amino acids. In COOH group, H is released as H plus ion. In amino acids from COOH group, H is released as H plus ion. This H plus ion combined with NH2 group, then NH2 group is converted into NH3 plus. Okay, this is the general formula of amino acids, or CHNH2 COOH is the general formula of amino acids. In these amino acids, H plus ion is released from COOH group, then COOH is converted into COO minus, then COOH group is converted into COO minus. Later H plus ion moves to NH2 group, then combined NH2 group, and NH2 group is converted into NH3 plus ion. So this is the another structure of amino acids. This is the another structure of amino acids, or CH COO minus NH3 plus, or CHCOO minus NH3 plus. This structure is called as dipolar ion structure or Zwitter ion structure, and this structure is called as dipolar ion structure or Zwitter ion structure. Because of this dipolar ion structure, because of this Zwitter ion structure, amino acids having high melting point values, alanine having high melting point value comparatively lactic acid. Okay, here alanine and lactic acid are taken. These two are having similar molecular weights. Lactic acid molecular weight is 90, alanine molecular weight is 89. So these two compounds having similar molecular weights, these two compounds having similar molecular weights, but lactic acid melting point value is 4 degrees centigrade, alanine melting point value is 297 degrees centigrade. Why alanine having high melting point value comparatively lactic acid? Here lactic acid and alanine having similar functional groups. CH3 group and COOH group are presented in these two compounds. Lactic acid and alanine having similar groups like CH3 and COOH having similar molecular weights, but melting point value of alanine is very high comparatively lactic acid. This is why this is happen, because of Zwitter ion structure, because of dipolar ion structure. Amino acids having dipolar ion structure, Zwitter ion structure. Because of this Zwitter ion structure, these amino acids containing salt-like nature. This salt-like structure amino acids exhibits high melting point values. Okay, students, amino acids having high melting point values because of this Zwitter ion structure, this dipolar ion structure. Okay. On electrolysis of amino acids, in acidic medium, it travels towards cathode. On electrolysis of amino acids in acidic medium, it travels towards cathode. Okay, here we take the Zwitter ion structure of amino acid. Here we take the Zwitter ion structure of amino acid in acidic medium. In acidic medium, H plus ions are present. These H plus ions combined with COO minus ions and converted into COOH. So in acidic medium, Zwitter ion containing positive charge. So on electrolysis, it moves towards cathode. On electrolysis, it moves towards cathode. Okay, students, on electrolysis, amino acids in acidic medium, it travels towards the cathode. Okay, in basic medium, it travels towards the anode. In basic medium, it travels towards the anode. For example, here we take the Zwitter ion structure of amino acid in basic medium. Bases releases OH minus ions, NH3 plus ion releases H plus ion and converted into NH2. These H plus ions combined with OH minus ion and converted into H2O. So in basic medium, Zwitter ion having negative charge. In basic medium, Zwitter ion having negative charge. On electrolysis, this negatively charged ion travels towards anode. Okay, students, in basic medium, it travels towards the anode. On electrolysis of amino acids in acidic medium, it travels towards the cathode. In basic medium, it travels towards the anode. So at certain pH value, the amino acid does not travel to either of the electrodes. In acidic medium, pH value is less than 7. pH value is less than 7. In basic medium, pH value is greater than 7. So at pH value less than 7, amino acids travels towards cathode. At pH greater than 7, amino acids towards travel anode. Okay, students, at certain pH value, the amino acid does not travel to either of the electrode. That pH is taken as the isoelectric point of the amino acid. At what pH value the amino acid does not travel to the either of the electrodes, that means anode or cathode, that pH is taken as the isoelectric point of the amino acids. Okay, students, amino acids are colorless crystalline solids. These amino acids are having high melting point values. These are soluble in water. Except glycine, all amino acids exhibits optical activity. Amino acids having high melting point values as compared to the compounds containing similar groups and having comparable molar mass. Okay, at certain pH value, the amino acid does not travel to either of the electrodes. At what pH value amino acid does not travel to the either of the electrodes, that pH is taken as the isoelectric point of the amino acids. Okay, these are the physical properties of amino acids. Okay, students, in the next class we discussed about chemical properties of amino acids.